Hello everyone, EDCON. I'm Adylin Zhou. I'm super excited to be here today with you all to share with you how smart contract oracles are unlocking the value of the DeFi revolution. So first, we're all in this industry because we're excited about how the blockchain will revolutionize supply chains, insurance, finance, and countless other services. However, there's a fundamental challenge for blockchains to fully fulfill this vision. The blockchain is an isolated database, and it's separate and unaware of what is happening in the real world, the world that you and I live in. The blockchain cannot communicate directly with the real off-chain world, and this is what we call the oracle problem. Blockchains gain their security from a distributed network of independent miners or node operators. And the blockchain's decentralized nature, though, prevents it from directly accessing off-chain information. Real-world information, such as financial market data from Bloomberg or the New York Stock Exchange, or event data from IoT devices or GPS locations, cannot be fed into the blockchain. Similarly, decisions made by smart contracts on the blockchain cannot be communicated off-chain to trigger payments and other actions. What we're missing is a communication layer between the on-chain and off-chain world. Because of this missing on-chain off-chain bridge, the majority of historical smart contract use has centered around tokenization. This is because issuing and tracking changes in token ownership is contained to on-chain movements. For example, if you gave me 1 Bitcoin, all that information of you handing that Bitcoin to me is tracked on the Bitcoin blockchain. However, the data around token transfer is all kept on-chain. Yet, tokenization is only one really small percent of smart contracts, or what their possibilities can be. Yet the true power of smart contracts is when we integrate them into existing legacy systems and infrastructure. It's when we connect these contracts to the real world that we build universally connected smart contracts. That's when we really see the power of smart contracts to change the world. We're all witnessing the recent meteoric rise in decentralized finance, otherwise known as DeFi. In just the last few months, we've seen the value locked in DeFi soar to almost $4 billion. Unlike traditional, tokenization, DeFi applications need to connect to off-chain data. They need to understand the price of an asset from multiple data sources, including both on-chain DEXs and off-chain centralized exchanges. We at Chainlink are working with many of the top DeFi projects, including Synthetics, Aave, Nexus Mutual, and many others, to provide them with this price data. For example, Aave, a popular borrowing and lending platform, needs to know the price of ETH to USD to calculate the collateralization rates on their loans. That ETH to USD rate is off-chain. In our previous tokenized environments, you only needed one part of the contract, the token generation contract. All that information to track token movement is on-chain. There was no need for external data. But now, with DeFi products and all the other blockchain use cases that we all want to see realized, your smart contract has a new part, an off-chain part. This off-chain part encompasses external data, enterprise systems, traditional payments methods, and so much more. In order to provide the same trustless securities that will guaranteed by the blockchain, which is why you want a smart contract to begin with, you need to have end-to-end reliability within your entire smart contract system. What we do at Chainlink is provide the secure and reliable mechanism to bring data on-chain as well as off-chain. This requires a number of new approaches through something called an oracle. We focus on creating a decentralized oracle system that validates inputs, provides access to payment outputs, and connects to various existing infrastructure and systems. We enable smart contracts, regardless of what chain they're on, to get all the inputs and outputs they need. So let's talk about how we approach this in creating secure oracles for Web3. First, we do this through decentralization. We have countless independent, Sybil-resistant nodes in our oracle network. Similar to the blockchain, decentralization is at the core. Next, these nodes provide security through various cryptographic systems. In addition to having the top industry node operators, we also have enterprise node operators. We recently welcomed Deutsche Telekom, one of the world's largest telecommunications providers, as a node operator to the Chainlink ecosystem. High-quality data is another key component. As the saying goes, garbage in, garbage out. Thus, our Oracle system focuses on connecting smart contracts with high-quality credentialed data. We also provide crypto-economic security guarantees based on staking to ensure that node operators behave honestly and reliably. Then we couple all of this with defense and debt practices. We layer on trusted execution environments, zero-knowledge proofs, and other secure approaches to ensure that the Oracle system is secure. And finally, all this is supported by a large open source community of trusted developers, node operators, academic researchers, and security auditors. We are proudly built on Ethereum and have been working with the top Ethereum DeFi applications. Ethereum is where we have the largest variety of data products available today. We also make Chainlink oracles available across all types of chains. We do this because by supporting more chains, we grow the overall demand for off-chain data. And when you have more demand for data, that becomes a greater market opportunity for data providers. This incentivizes data providers to provide more data into the blockchain ecosystem overall. And this benefits everybody. It's a win-win situation because now developers and smart contract creators can have access to more high-quality data. The Oracle problem is how to bring data into a blockchain, right? We talked about that. However, just as decentralization is important to the blockchain, decentralization is also critical to the Oracle mechanism. That's why it was the number one point that I mentioned earlier. In this example you see here, a centralized Oracle becomes one node and is a single point of failure. Even if your smart contract is built on a decentralized blockchain, using just a single oracle centralizes your entire smart contract. It puts your entire smart contract at risk. Your smart contract is only as secure as its weakest link, and if it's a centralized oracle, then that becomes the weakest link. So just as your blockchain that your smart contract is built on is decentralized, your oracle system needs to be as well. We address the decentralization challenge by having fully independent Sybil-resistant nodes. We focus significantly on the quality of the node operators. And we also make node networks of no fewer than 7 nodes. Our typical networks have many more nodes, some as many as 30 or more. As a user, you also have the ability to see the quality of these node operators, which make that information extremely transparent, and all the data that's generated is open and visible on-chain. It's something that anyone can analyze, so we're very transparent about that. Some of our awesome community members also created the website called reputation.link, and it features tons of great charts and graphs that allow you to review node performance history. You can compare them against a variety of metrics such as transactions, numbers completed, response times, and more. Another super critical part about oracles is data quality. As mentioned, garbage in, garbage out. Even if you have the most centralized oracle system with the best security guarantees, if the data that you're feeding into the system is junk, then you will get garbage coming out as well. So this is a serious problem that people need to understand. and it's one that creates a significant risk for DeFi applications. If the data that you're using is not right and not good, then it's triggering the wrong contracts and triggering things incorrectly. So credential data is a must, like absolute must, for any contract of value. Chainlink was built from day one to access this high quality credential data. And we've baked that ability to access credential paywalls into our original architecture. Many of the other Oracle systems out there do not have this ability to access premium data. Instead, they rely on free, low-quality data pulled through complimentary free APIs. But this doesn't work. It's as if you're trying to watch a great movie, but instead you're watching a pirated version that someone filmed on a camcorder in a dark movie theater with heads bopping around, right? That's not the way to watch a good movie, and that's not good quality. Similarly, when you have good high quality data, you need that into your Oracle system. And so in our price reference contracts, we only use premium data sources. We don't pull from any single exchange nor any free open APIs. We work with professional, experienced data providers. We also provide a lot of customizability to the user. Here you can see a node job ID that defines a specific work that a node will be providing, as well as the actions it's taking to assure the quality of the data. This level of definition is important because as your contract increases in value, which we hope it does, you will need to prove this to users. Users want to understand how you're triggering their contract. Another thing oracles need to do to maintain their security and reliability is through the use of service agreements. We use on-chain agreements that define all parameters under which a node will be delivering data to it. As more data and usage flows through the Chainlink system, you'll also gain additional information about the reliability and performance of nodes. In the system of a web of trust, where node operators have a history of performance, you can start understanding how trustworthy a node operator is by its past history. And finally, crypto economic security from staking. So crypto economic guarantees are deposits that the nodes will perform as promised. Link tokens are used to guarantee that the data is properly delivered. And if that data is not delivered under the right conditions that are set in initial contract, then the operators will lose their stake. This is very clear motivation for them to maintain the security of that Chainlink node. Finally, Chainlink is incredibly customizable. We've discussed how you can decentralize the nodes. You can also decentralize at the data source level. You can decide on the number, the type, and the sources of data that you want to pull from. All that is up to you. And with that, this is how Chainlink is able to empower the growth of DeFi. We create that bridge for that off-chain data from exchanges and DEXs to bring that on-chain into your favorite DeFi dApp. And most dApps find it easier to use a pre-built Oracle system like Chainlink rather than build it from scratch. As we mentioned, there's so many components around security, reliability, and research that goes into thinking about how to create a solid, secure Oracle system. And by just using the plug-and-play system of Chainlink, we greatly reduce the amount of time it takes for a DeFi developer to take a dApp to market. And by doing so, we allow them to build faster and build great products for end users. So if you're interested, you can check out some of the feeds live. If you go to feeds.chain.link, there's tons of different price reference contracts that are already out there being used live in production by some of your favorite DeFi dApps. DeFi is just the beginning. We're super excited to see where this industry goes, and we can't wait to see what else we can create with connected smart contracts. Thank you.